So yeah, it's a Java puzzler session. Next gen, I will explain why it's a next gen. And let's see why my clicker doesn't work, because some Wi-Fi screen appeared. Okay, we don't need this. Okay, cool. Now, just a quick introduction to myself. I work as a solutions architect with a company called Hazelcast. Again, I guess this Wi-Fi thing appeared, and I will need to disable Wi-Fi. This thing is happening. I don't like it. Okay. Good, good. I also work as a developer advocate at Hazelcast, so I'm talking to developers about technology and stuff. And I deeply care about Java because Hazelcast is written in Java, and we do a lot of things with Java. Also, in internet, you can follow me at GMUSSA. And yes, I'm a very interesting person, as you might see. All right, so actually, there's supposed to be another guy. We usually run this show together, and I will explain why it is important to run it like together. So the thanks to this guy as well. His name is Baruch. He's in DockerCon right now. So this is luxurious life of international conference speaker. You don't know like where you end up today. So and the thing is that this guy is supposed to bring the T-shirt. So I will pass all the blame on him. So if you will answer correctly, I will explain it later and why it's important. But I will talk about this a little bit later. So now, who knows these two guys? Yes. It's Neil Gaffner. So yes, George Block and Neil Gaffner, they're fathers of Java, authors of original Java puzzlers. So that's why like we're doing like next generation of Java puzzlers, and we're standing on the shoulders of the titans, and trying to do our small thing. All right, I want to say a couple thanks to some of the contributors, because the Java puzzlers is a community-driven effort. So the people submitting puzzler to us, so we can play around and present them on the conference. Tagir Valiyev, he's our friend from JetBrains. He contributed a lot of Java puzzlers in the season 1. It's actually season 2 of Java puzzlers. The guy knows like Java, and his kind of reputation on Stack Overflow, as you can see, says a lot about him. So another guy is Sergey Kuksenko. He's a performance engineer at Oracle. He also contributed Java puzzler here. Guy also knows a little bit of Java. So he worked on optimization of the lambdas during Java 8 release. Right now he's working on HTTP2 client for Java 9. And Cedric Champer, he's an engineer at the Gradleware, the company that worked on the build tool called Gradle. How many of you use Gradle? Okay, cool stuff. So, and he also contributed. To this talk. Okay, so a couple rules on Java puzzlers. So there's supposed to be 2 people, but it's going to be me, and I'm going to entertain you with the some probably funny jokes, some probably puzzling questions. Now, funny puzzling questions. You need to vote. This is very important because it's like an interactive session, and you need to vote for different options that I have. So the couple of things why it is important. So first of all, like you might not even know answer, but if you will guess, and maybe if you guess successfully a couple of times, the person who sits next to you will think you're smart, which is awesome, right? And yes, and if you have a desire to tweet about this, go for it. Java Puzzlers NG and the Philly ETE, you can tweet about this. And most importantly, no cheating. Like you cannot use IDE, you cannot use REPL. In Java 9, there's a REPL that allows you to evaluate the code. So no cheating, no Googling, etc. So it's gonna be fun. All right. So let's run the quick test. How you understand that you need to vote, right? Like which version Java are you using right now? Java 7. All right, couple people. Java 8. Nice. It's a good thing. It's a good sign. Java 9 in production. Cool stuff. We have a couple people who actually want to live in a very, very dangerous way, right? Okay. Java 6. Okay. Couple shy hands I see. Java 5. All right. Java 2. Anyone? That's good stuff. That's good. So the number of people over the years when we started doing this like 2 years ago, it's kind of decreasing towards Java 8 and Java 9, which is good. All right. So this is kind of a facial expression that the people usually experience during the Java puzzlers talks. So this is okay. It's fine. This is exactly how you're supposed to feel. This is, whole point of the Java puzzlers to make you feel like you know Java, but what the hell is going on? All right. It appears so something is incredibly annoying happening with this conference Wi-Fi. Just give me a second. I will just simply say so. All right. We can do small. That's something that everyone knows. A story about Russian hackers. So we don't know, like you don't know, I don't know who these people on these pictures because the faces are blurred, so we don't know. And they're trying to hack a bank, right? So let's design this like a hackable bank system. And we're going to use like something that you know and probably use a lot, a semaphore, right? And with semaphore, we kind of designed a system that allows us to do like withdraw and the system that allows us to check the balance, right? It's easy enough. So there's a couple options that I will provide to you. So who thinks it's A? It's going to be a legal argument exception because you cannot create a semaphore with negative value. You need to vote. You need to vote. So no one thinks, okay, I have one person. Okay, cool. So B, unsupported operation exception. You cannot drain permits on negative. Guys, you need to vote. You need to vote. Who thinks it's 0? All right, we have a couple people. Who thinks it's minus 42? Okay, all right. And the right answer is 0. And this is kind of unsuccessful robbery. So one of the moments when you thinking that, okay, so the bank robbery is going to go smooth and everything is going to be fine, but not exactly. All right, so who can explain? Who knows why? Why it's 0? Anyone? So, okay, if you will provide the right explanation, I promise I will send you a t-shirt. Because the guy who was supposed to brought t-shirts, he's not here, and I will be responsible for sending you a t-shirt. Who want to try? Yeah, it's close. It's close. It's obviously you know it's because velocity is 0. But anything more? Yeah, it's actually you're on the right track. So the thing is that, first of all, I don't know how many of you know this, but you actually can do the negative, can reach semaphore with negative number of permits. Like, okay, so now we learn what needs to be happen. And drain permits actually says acquires and redo all permits that immediately available. How many permits immediately available? Minus 42. What's supposed to be answer? Why? Minus 42 is available. Minus 42 is supposed to be returned, right? But this drain permits thing is a little bit different. So, and actually we submitted this as a bug, and Doug Lee himself answered that it's not a bug, it's by design, and they fixed the documentation. Or obviously they're gonna fix documentation in further releases. All right, so a little bit warm up. You know how it works now. Let's talk about singleton. Who loves the singleton? Like not write singletons, but drink singletons. Anyone? Single mode. All right. So do we have like a Java 5, Java 6 guys here, right? So they're supposed to crack this this puzzler without any issue, right? Okay. So collection empty list equals connection empty list. So it's going to be the same over and over the time. So anytime you will call it, you'll get the pointer or like reference to the same object. And for iterator, so obviously there's a couple options. So I guess I covered everything here, right? True, 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 false, false, true, false, false. Okay. Who thinks it's A? It's a true, true, and both these methods are actually invoking singletons. Guys, you need to vote. It's going to be fun. Remember, you need to appear smart. Maybe there's some recruiters with like a future job, and it will recruit you right after the session. Okay, cool. Who thinks it's A? Okay, we have a couple people. Who thinks it's B? All right, cool, cool. Who thinks it's C? All right, couple people. And who thinks it's D? All right, so the right answer is, come on guys, this is Java 6. We know this, right? This is Java 6. All right, so now this is another exercise, Java 8, right? Java 8 introduces new awesome stuff like streams, lambdas, and another thing, another special type of iterator called split iterator, right? Now, same options. All right, let's get to vote. Who thinks it's A? It's a true, true. So Java, consistency, backward compatibility, and stuff, A. All right. Who thinks it's B? True, false. Okay, we have a couple people. Who thinks it's C? Okay, good, good, good. Who thinks it's D? Interesting. So, and the right answer is the, obviously, singleton strikes back. Who actually can explain? Who can explain why it's happening? I remind you, like, I will send a t-shirt, awesome t-shirt. Anyone? Like, your lucky guess. Why this happening? No one? Okay. So, when you like start learning Java 8, you started learning about something about stream. And the thing is, stream is a special type of, it's not data structure. It's just a way how you can define different pipelines, how you modify the data. But the thing is that stream, first of all, it doesn't modify initial source, and plus stream has a state. Even EmptyStream has a state. If you cannot touch a listener on the stream, even on the EmptyStream, it means that there's somewhere is a state. So as you can see, it can be operated only once, even if it's EmptyStream, right? And you can assign the listener. So in this case, split iterator has empty split iterator has the same semantics as an iterator, and the empty collection has EmptyStream has a different semantics than empty collection. So because stream will be created each and every time. Okay? Okay, cool. So let's talk about, it's actually one of the first questions with like a banding logic. So here is like a premise. So in this question, I'm going to talk about the identical objects, but not in the sense as we usually talk about them in Java, right? So first of all, identical is an object that has the same state. Non-related to hash code or equals to any point. And not related to like the reference or in the memory in any time. Okay? Like I said, it's kind of a special type of logic here. Now, here's interesting code for you, right? I have an array of lists, and I will execute method set all to populate. So what's going to be in the result? Again, here's a very obvious answers. So absolutely identical empty list, they not might be, have the same hash code or equals method, but they're identical, meaning that they have a same content. Absolutely identical non-empty list. Non-identical empty list, non-identical non-empty list. I covered everything, right? So who thinks it's A? Okay, who thinks it's B? All right, who thinks it's C? Couple people. Same people who work for A. And D, non-identical, non-empty list. Anyone? Any takers? Okay, one gentleman. Yes, cool. Okay? Does it make sense? Does it make sense at all for anyone? Okay, so who Who can guess or try to explain what's going on here? Come on, guys. Okay, please. So what's going to be actually, in these two arrays? Okay, so the first part is correct. So we will create a two arrays, but what's going to be in the content? We noticed that there's given two arrays, but why are they not identical? And what? What kind of parameter new operator accepts in array list? So when you create a new array list, you can pass a parameter to constructor of array list. Okay. Now you know just deconstruct the sentence and why does it C is the right answer. Okay. All right. Okay. So first of all, like I said, all accepts a generator that will accept in then index, which is, yes sir, you were correct. Now, the array list, you sir said right, it's initial capacity. So in this case, it will create array with two array lists, which would be empty, but with the different initial capacity. Does that make sense now? Okay, it's cool. It's a good question. So so basically it will pass the index because compiler right now is much smarter, and it can you're passing this function that might appear similar that it expects. So now in this case we'll have a totally useless code with totally interesting puzzler. All right. So let's talk about like a single abstract method and the part which is like single. All right. Interface. So when you single, you can do party hard, you can drink in, and pretty much it, right? So how you would create the method which will single and happy? So in this case, I have an interface single, and I'm extending interface single to create interface single and happy. So couple options to you. So first one is when we're talking about single abstract method, how it's possible to have multiple methods in a single abstract method, right? So in this case, it's going to be like compilation. So the B option is the problem with method party hard with type T. This one. Problem with drink in method. Remove one of them and everything will work. And everything will work fine, and party hard, drink in, merge, and the single happy leave one abstract method. So A, who thinks it's A? It's gonna break. Okay, two people here. Who thinks it's B, problem with the party hard method? All right, so 1, 2, 3 people. And C, problem with drinking method. All right, good, it's the most popular. And everything will work fine. Why not? It's puzzlers, everything possible, right? Okay. Who answered B? Anyone? Who wants to explain why? Why it's a problem with party hard? Yes. For what? Correct. So the thing is that when we're dealing with this kind of situation, the object has a bigger kind of visibility, or it can consume things with smaller type. The string is a subset of objects, so it's covered. So this is why removing the party hard will solve this. And drink in also will be merged with object with T type. So in this case, if signature was overridden, and the equivalent will produce, there will be no compile time errors. It will just produce new type in compile time. All right. So Russian hackers want to strike back. Now they figure out, okay, they cannot rob the bank. Now they can rob the richest people. So because software written in Java, and Java developers know Java, and the hackers know Java, so let's hack into it and analyze the accounts first. So this is a typical code that we see might be in many places in our code base, right? So we have a hash set that we produce from array list of Gates, Buffett, Bezos, and Zuckerberg. And we printing the account. And follow the logic. Again, another Russian, because in Russian language we actually have a double negative, so we can say, you know, very weird sentences and they would be not understandable for the rest of the people. So that's why there's bending logic. So which given statement is wrong? So remember. So A, set is ordered by hash code. Is it wrong or true? The order is predictable across multiple runs of JVM on the same machine. Is it wrong? Order of elements in the set is not predictable, which is predictable. And D, statements A and B are correct, which is wrong. Okay. Now you need to vote. Now you need to vote. Okay, so for, who thinks it's E? Is that the statement that set is ordered by hash code is wrong. Okay, we have one person. B, order is predictable across multiple runs on the same machine, which is like wrong statement. Who thinks it's C, which is wrong? Okay, because is order of elements in set is predictable. Cool. And who thinks it's D? Why not? It's weird, right? Okay, cool. And the answer is C. Oh, where's my Russian hacker? Yeah, it's kind of fun. Okay, who can explain this? No, it is right. The order of elements in this set, in hash set, is predictable. Because underline it. No. Okay, let me explain this. So, order of elements in set is not predictable, which is wrong statement, meaning that order of elements in set is predictable. Because the hash set is based on implementation. Here's the hash set. That's okay. So this is basically implementation, right? This is how it works, and we know this. It's not a puzzle here. Okay, so the FBI will strike back. So what's the best thing to prevent anything from like be hackable or hacked by someone? Let's upgrade to the latest and greatest Java, right? So just we have a gentleman who have Java 9 in production, so this is our way. So let's do this. Now, in the Java 9, it's actually a pretty nice construct that now available for our disposal. It's the static method called off. So you can create set of elements instead of putting this like weird construction when you have a hash set, array list, of list, etc. Now, in this situation, how this will behave? Same options. Too fast. Too fast, too fast. All right. Too fast. I need to fix this button. Okay. The cool stuff, yeah. This is what we call in Java consistency, right? So we basically switched to a new version and we applied, let me show you. Yeah, this is how it looks like if I run it in the G shell. So meaning that order is not predictable across multiple runs on the same JVM. Who has any idea why it happens? Yes?
Because here the underlying implementation isn't hash set.
okay, close, but anything else? It's, you can kind of say it's true, but any more details? Well, you kind of know. You can open it in runtime and see what kind of implementation. All right. So the thing is, yeah, this is another episode of very fun robbery. But the thing is that in Java 9, they actually in implementation is a little bit more sophisticated. And what they added here is the salt that would be generated during JVM start. So basically, this is why you cannot rely on the order in this case. And the implementation, I don't remember like what's the implementation name. It's something like with internal package basically. But if you have like a colleague, I'm not saying like you, like you have a colleague, you have a friend who writes the code and production code that will rely on order of the set. So, you know, talk to him. Which is, you shouldn't rely because set, there's only one guarantee that set provides you is that there will be no duplicates, right? Ordering, you can have in list or queue, but not in the set. All right, so another one, Java 9 puzzler. So we know that in Java 9, the Oracle engineers and the community, they want to work on the project Jigsaw, and they want to introduce the model system in the Java platform. So the variable statements also follow the logic. What these statements are correct in Java 9? I expect from you, sir, a right answer. So some of these statements. So when you when you convert your application to module, your class path dependencies will be resolved correctly. So in the Java 9 model system now, you need to define this the module metadata. If you have a dependency, if your one of the dependency was converted to the module system, you have to declare it in the module info, which is like a metadata file. Once you added module info, you still need to have dependency declared in the module info and the runtime in the typical class path thing. And the none above is correct. So let's work. Who thinks it's A? So the first statement is correct. So when you convert it to module, like everything would be work magically. Okay, no takers for magic. B, if one of dependencies was converted, you need to declare it in the module info. All right, couple people. Who thinks it's C? You actually need to define it in two places. Okay, I have C, 3, 4 people, and none of all is true. So module system, this is a blessing. We'll give it. It's going to be awesome, and everything is going to be cool. All right. So right answer is C. And as a matter of fact, it is not a blessing. It's not a good thing. It's something that we need to deal with. In particular, when you define your module info, you still need to be responsible for constructing correct the class path. So the build tools will be able to generate this, like the Maven or Gradle. That's why this puzzle was contributed one of the developers of Gradle. So the module info, metadata, and you still will be responsible for generating the right class path. Okay, this is kind of our impression about this module system, right? We're extremely waiting for this system, right, in Java 9. Okay, so let's talk about the famous characters in our Java puzzlers, like the expendables guys. They were in the Java puzzlers in Groovy puzzlers, Java puzzlers. So let's kill them all. So here's the code that will do iteration of the collection of expendables. We have a Sly, we have a Schwarzenegger, we have a Bruce Willis, we have a Jean-Claude Van Damme, we have a Dolph Lundgren, we have a Jet Li, we have Jason Statham, who else? Randy Couture, yeah, named Hemsworth Jr. Okay, so So how are we going to do this? So we're passing the collection of expendables, and we're taking the iterator, and for each remaining, we call remove. Pretty simple code, right? Actually, it's not. So with this combination, if we're passing, we will kill them all. We kill only even elements in this list. They all survive. Or we kill only odd. Or all answers are correct. So you think you will. Who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? Who thinks it's E? Okay. Good job. Told you. So this is what's gonna happen in this situation. Everyone's died. Okay, who can explain it? Yes.
Get a concurrent modification exception?
This is good question. This is good answer for the Java Puzzler Season 1 because we have a lot of concurrent modification exceptions, but not. In this case, you see, all answers are correct. So how they can be correct? It actually depends on implementation. So depends on the way, what's the goes inside the collection, because you see here, it was a collection. So it's not the define the type. So based on the implementation, you will get like a weird results. So in this case, the simple answer, never do this kind of stuff. So you either go through the iterator, or you either going through the methods that are suitable for iterating over a collection. But do not try to do this like both in the same place. Okay. So another reference in my Russian childhood. So we have this thing of different variety of brands that we can afford. So like if you can see, there's Adidas, ABCDs, Adivor. So basically, Adibos is my favorite. I was wearing Adibos all the time. So yeah, subtle difference. So basically, they look pretty much the same, especially from the back. But let's talk about Java here, right? So we have the predicate interface, like it's a functional interface that allows us to do like something. It's basically predicate, right? So method that will return Boolean and will receive some type, and it will say yes or no. Now, in this situation, can we use this construction? Can we use lambda or method reference? So it's pretty simple, right? It's Java 8. Everyone knows Java 8 here. So who thinks is A? Both will work just fine. Okay, 2, 3, 4. Who thinks is B works and the method reference fails? A couple people. Okay, good. Method reference works, lambda fails. And they won't compile. Come on, guys, Java 8. Obviously, they work just fine, right? So, what's the too fast? Okay, now different. We're moving the type from the class into the. Now I need to fix this because it just ruins my presentation. So now we're moving type to the method, and how this will appear in this case. You already seen the result, right? Yeah. You wanna vote? All right. So the method reference works and lambda fails. Who knows why? So let's have some room for discussion. Compiler will figure out, but what's the problem? Why it works in one case, why it doesn't work in another case? Why it doesn't work in Well, it will work fine because equals is just a from object. It's not only from string, right? Yeah, but this is not the problem. Yes. Exactly. So the thing is that you can use it in method reference, but okay, yeah. Let's watch some funny GIF that we will destroy the code when the code destroys us. Okay. And the problem is here is that this is Java, and we have this definition in Java language specifications that lambdas cannot be generified. So the classes can be generified, and generic function type there's no such syntax in Java. So it's something that you know, it will work for method reference just fine. So to answer your question, it will be inferred just correctly. But in this case, there's no such syntax. And the thing is that you will see this. It's kind of funny, like when you run this in IntelliJ IDEA, for example. I don't know, I haven't used Eclipse, but IntelliJ IDEA would suggest you convert this code into method reference. So in this case, it will work. Okay. Any Star Trek fans in the room? Okay, cool. So yeah, obviously, like next generation, right? So we kind of thinking, okay, so the George Block or Neil Gaffner, they were like original Java parsers, and we are next generation. We are Picard and my friend Captain Riker, who's not here today. But Spock is, anyways, the best character in the universe. So let's have some fun with it. All right. So we have a stream of elements. We're passing through the method sequential, executing filter. After that, we run the collect, and we want to see some result. Right? Pretty simple. This is result by number A, B, C, D. Who thinks it's something else? Maybe I missed something. Yes. Am I only one who thinks that the data is not supposed to be in this list? Okay, jokes apart. Who thinks it's A? It's going to be data here spot. Have a couple people here. One gentleman over there, thank you. Who thinks it's B? Okay, 4 people. Who thinks it's C? Good job. Who thinks it's D? Who thinks it's E? Cool, my man. All right. So I would point out one more thing here, and it will allow you to sort of rethink your answer. So think about this one. What this stuff is doing? Who wants to like rethink the answer? Who thinks it's A still A? Okay, so we already have less arms. Who thinks it's B? Still a couple people believe in themselves. C. D. E. I'm just kidding. So the right answer is C. And who can explain this? Anyone? Yes. Okay, that's a good point. So the reason why I point out here is that is it gonna be calling the new preset each and every time when each element will go through the stream? Yes, you're right. So can you explain why? Beautiful. But what is the difference between A and C? Correct. So the tree set actually has a natural order because it's backed by tree map, as far as I remember. And the thing is, there's another subtle difference. So if using this syntax, the stream will remember this object. And in this situation, if we will use lambda but not method reference, it will be creating the tree set each and every time. So with this syntax, we will end up with something like this, right? Because it just simply will pass it. It will create multiple entries, multiple entry sets. After that, it will run the list on this, and it will, print it out. Yep. All right. Let's talk about the captain obvious, and we'll talk about another very awesome construct that we have in Java 8. It's optional, right? The optional is awesome. The optional here to prevent us from null pointer exception, right? Awesome is great. Or optional is great. So let's see how it works. So we have the optional of obvious, or else get null. We will get empty optional. After that, we execute map on null. And if it's null, we will return obvious. Isn't it obvious? Sorry, I couldn't help. I guess, again, like, it's pretty easy, right? I covered, like, pretty much every scenario. And you see, our guy, even though we have optionals here. So who thinks it's A? So everything would be obvious. Okay, we have some people. Who thinks it's B? Obvious and null pointer exception. Okay, many people. Good. C, null pointer exception and obvious. Okay, and the third one, null pointer exception, null pointer exception. Isn't it obvious? So this one will never happen, right? Because optional will just return this guy. And this is supposed to be, also never happen, right? But why it actually is happening here? Who can explain? Like, why this throws null pointer exception? Correct. So in documentation of the map method, this guy will throw null pointer exception. Its function that will pass a null is null. So more stuff. So more interesting stuff in Java 8 that we have. Another question about identical objects. So when agent A equals agent B, a little bit harder. Okay, so let me explain what we see here. So we have this the consumer the functional interface, and we can define this in the 4 different ways. So in this the first case it's lambda, in the second case it's method reference, and in 3 we define it like with optional, and lambda, and with method reference. So who thinks it's A? None of us. Okay, who thinks it's like 2, the option 2? Okay. Actually, options. Okay, guys, I'm just checking. Are you still with me? Okay. So I know it's hard to digest. Okay, so let's see. Like, what kind of the constructions are actually correct? So all of the constructions are actually correct, and everything is going to be working fine. And in all these cases, object A is going to be agent A is going to be equal to agent B. Who thinks it's like it's a B? Only in the third case. You probably also remember from the very beginning when we talked about the lambdas versus the method references. Okay, who thinks it's only 3? Who thinks it's only something else? Something else. It's a solid choice, yes, obviously. Now, it's only 3. and it's kind of not quite easy to digest. All right, so who can explain why in the case of 3, in this construct, we will have only, in this situation, only have a ability to compare this to objects? Anyone? Yes. Is it? I guess the question here is like when the particular code will be evaluated. When it will be evaluated on the runtime, when it will be evaluated on the compile time. Mm-hmm. Okay. So it's possible to reuse only in function. In other cases, you're right. So in the compile time, this will be it will produce in the compile time. So consumer accepts parameter. If it accepts a parameter, it has a state. It needs to have it somewhere inside. So in supplier 4, it has a state where we pass it here. Yeah. So like 4 has state. Yes. So in this case, it will have a state. So in this case, they will not be equal. But in third case, they will be equal because they will be evaluated in the compile time. All right. So in terms of conclusion, like you saw right now, like pretty nasty code, and usually we not recommend to do anything of this in production. So here's a couple of takeaways that you probably can take home today. So first of all, always write readable code. The syntax of Java 8 allows you to write more concise code, but in a couple weeks or in a couple days or in a couple hours, you will figure out that you don't know or you have no idea what this code is does. So write writable code and do not use the construct for the sake of using this syntax construct. So when you need to write this like a beautifully organized code, always comment things. It sounds kind of very logical, but you cannot imagine how many times the people would say, "Who wrote this?" And after that, it goes through the like a git commit and sees, "Okay, so it was me." So yeah. So but sometimes it's just a bug. In this section, in this season of Java Puzzles, we didn't have any bugs. But in the previous, for example, we faced some of the very in some cases. It might just be just a bug in JVM. And obviously, if you see the bug in JVM, you can submit it, and hopefully it will be fixed in the next release. Use right tools. Use right tools for doing the right job. So things like the static code analysis, the things like the IntelliJ. I don't know. Like I use IntelliJ IDEA. It has a pretty cool features where it can detect certain problems. And in this case, it will help me to write good code. Or you can use different tools like find bugs and run the static analysis. Sometimes you need to just read a Java doc, because in many cases, many behaviors already well documented. You've seen these examples with a semaphore, which it looks kind of obvious from perspective of usage, and we use semaphore a lot in our production life. But in situation when it's kind of like a negative value, questionable. And plus all these like methods they provide the exceptions when they throw an exception. So you need to read the manual. It's useful. So and do not abuse lambdas and stream. So also in the tools like IntelliJ. in the recent release, they released this feature that allows you kind of turn lambda in or like a stream type of back into the for loop. And sometimes people say, no, it's useful for debugging. You can turn it back, see what's going on there, and after that turn back into lambda. But to prevent this, do not abuse lambda in string. So we have more. We are already working on the new version, and we have a pretty big number of mind benders already coming. So if you see some the puzzlers that you think you can contribute, just send it to the puzzlers at jfrog.com. He's my colleague. He's collecting them, and he will send you T-shirt as well. So if you like it, do not forget to the praise Java puzzlers on Twitter, or if you will get the like a rating thing, please vote for this talk. So you can always tweet this in the Java Puzzlers MG and the ETE. This is my Twitter handle. If you have some questions or you answered correctly and I promise you T-shirt, just write me. If you did like it, that's very important. So feedback is always useful. So there's a special type of form that we accept like all feedback from you guys. And here's the link to slides. You can go there and download like a slide presentation and think about this in the free time. So apart from that, I'm done with my talk. Thank you very much for your time. I hope it was entertaining and useful for some of the people. If you have some questions, again, you can always reach out to me on Twitter. And thank you very much.